In this model, I'm going to study batch versus one-piece flow. We're going to do 3 different scenarios. In this first one, we're going to compare the batch in the top sequence with no batching on the bottom. So parts are going to be generated in both of these lines once every second. We're going to make 9 parts total, and the batch size is going to be 9 parts. And the machines, that's this with the gear here and the gear here. So we've got 2 machines on each line. Machine 1 and machine 2. So we got 2 on each line. They're going to be processing the parts, and they take 1 second each. The conveyors, that's these lines here, they all take 1 second. We're going to assume that the packing and unpacking takes no time. We want to compare it as accurately as we can, just studying the phenomena of batching and unbatching without the actual time it takes to do the batch. So just to keep it as fair as we can. So we're going to go ahead and run this and compare the two. So basically on the top, it's going to make a part. It's going to, when it gets 9 of them, it packs them, sends the pack on the conveyor on a pallet, unpacks them, the machine processes them, they get packed up again on a conveyor, unpacked, machine processes, and then they leave. The bottom one does the same thing, except they go as one piece, no batching, no packing. So a little bit simpler. So let's go ahead and run this. So we see the bottom's producing, they go straight through. The top one just sent the first batch over. It's now being processed. Okay, now I'm going to pause it. Note that the bottom one already finished. The last part went off the system. So definitely in this scenario, much better. Now it's unpacking. It's being processed. And finally it's getting done. So visually you could see a big difference in the 2 scenarios. So now we're going to do something similar, except this time we're going to do 3 types of parts. Okay, so this is going to produce 9 of one type, 9 of another, 9 of another. The bottom one is going to mix them up, kind of like a job chop would, where you get different parts from different places. So let's go ahead and see how this one does. So you see the first one's producing, they're going straight through. And the second one's still at it. Or I'm sorry, the second one's still going through it. Okay, now notice the bottom line. Okay, so it's just, the last one's going to come off the part. Looks like around 31 seconds. 32 seconds. And the top one's still working at it. So this one took about 47 seconds. So it really is quite a big difference. Now, it's not a fair comparison, okay? So you shouldn't stop your analysis here. We made the assumption in this model that there is no setup time. Let's see the impact of setup time, because that's a very important part of this. Because one reason you batch is to take care of setup time. So let's study setup times a little bit more. And so I'm going to go ahead, stop the model, and let's go look at setup times. So now we've got the exact same model, except now we're going to look at the impact of setup time. So let's assume that each machine, when it changes the kind of part it makes, takes 1 second to set up for that new kind of part. All right? So let's see which one does better in this case. So you got to think about this. We're having 2 opposing forces, so to speak. We've got one where you get the efficiency of not having to batch, which we saw very clearly in the previous 2 examples. But the opposing force to that is the inefficiency due to having to do more setups. So at 1 second setup in this model, let's go ahead and run it. we can see the bottom one is actually getting a little bit more of a queue now, because it's taking, each time a part is on the machine, it takes 1 second to process the part, and because it's changing the part every time, 1 second setup. The top one only gets a setup for the first one of the 9, then the next 8 has 0 setup time. So in this case, we're seeing there's a close balance, actually. I'm not sure who's going to win. It's very, very close. Okay, so the batching actually won by a little bit on this one because it didn't have to do setups. So in this case, if you have a 1 second setup per part, the batching, you were actually better off doing the batching. So this really gives you the importance of reducing that setup time. When you do a lean project, the setup time needs to get as low as you can get so you can get close to the one-piece flow. If you can't do that, you're going to have a problem. So in this particular one, if you want to go ahead and play with this model some more and see the impact of various times, you can go ahead and do this. You just left click on this, right click and say Input Editor, and that'll open up this here window, and you could just change these times. So if you want to give it say a half a second setup time, and you want to give it 1.5 second processing time per part, you could do that. One thing to note, just hit a different line or make sure to hit enter so that it registers, and then you close it, and then if you rerun it, it'll run with those new times next time you start it. So I'll let you go ahead and try different things how you want. But the takeaway lesson on this one is you need to reduce the setup times so you can get the one-piece flow. If you can't reduce the setup times, it's going to be very difficult.